Welcome to yet another episode of HVACR Verse. I'm your host, Kevin Stiles. I have my lovely assistant right over here, Miss Madeline. Go ahead and say hi.
Hi,
What are we going to be learning about today, Maddie?
what the thing do?
What the things do. That's a good answer. We're going to be talking about ECM motors and what ECM motors, how they operate, the different types of ECM motors. So, what is an ECM motor? ECM stands for electronically commutated motor. Then what makes up an ECM motor? You have the module, which is your ECM part. Then you have your three-phase brushless DC motor. And inside that three-phase brushless DC motor, there is a permanent magnet rotor. That rotor is permanently magnetized. And there's a reason for doing that because we're not creating the same type of electromagnetic field that we were before. So this ECM module is taking single phase power and converting it into three phase simulated DC. And then there's three types of ECM motors. You have your constant torque, which is your X13s and your Enduras. And then you have your constant airflow, and then you have your constant RPM. The constant airflow, I believe, works off of that's a true variable speed motor, to where it's changing the speed based upon the signal coming in, and then the the constant RPM works off of the fact that it just has like a what they call a Hall effect sensor that's monitoring how fast it's turning, and all these motors work off of a low voltage signal that comes in. It gets either 24 volts, and then some motors in the case, they get a 0 to 10 signal telling them how fast to go. On the X13s, which are a constant torque motor, they get taps 1 through 5, which takes it and makes it go, hey, we're going to speed 1 being the lowest, speed 5 being the highest, and that's how it determines. It gets a 24 volt signal on those taps. Now, we're going to go over and I'm going to show you how these motors work and how they get three-phase signal to them, what controls these motors, and they're nothing really complicated. They're pretty easy, and there's a lot of drop-ins to replace that stuff. Right, Maddie? So let's move over to the table and do that. All right, so I got a ECM motor that I separated the module off of over here, so that way you guys can see. And I'm utilizing this Trade Fox subcode jumper keying. You guys ever think about this is a gimmick or not? This little tool is actually coming pretty handy for a lot of things for me. I'll do a review on it. I just bought a bunch of my technicians this item because it was actually pretty helpful for me. So the way I have this wired up, this is a 115 volt module that's going to convert to three-phase DC, and we'll show that. So right now I just have a little switch over here that's plugged into the wall, and we're going to turn that on, and you can see that right now we don't have any power to the module. I'm going to put the meter lead in right here, and this pierces this wire, so it makes it nice and handy. The other thing you can do with these is you can actually take a wire, and I'm not trying to do a review on this right now. You can take a wire from here, plug it into this little needle piercer, and I can take it, pull the lead out of my meter, and plug it right in. It's actually pretty nice. So I'm just going to put this back so it'll be easier to move my leads around. So right now there's no power, obviously, as you can see. We have no power going to this module. But we apply power, and you'll see on the screen here, oh, that's not grounded on there, that's why. So I'm just going to put this alligator clip on here. Let's go ahead and do this. Put this lead in here, go to my neutral, so that way we get constant power. You can see. So you can see we have 120 volts going to this motor. And it's not running. It's not running because we're not sending a 24 volt signal, and that's why we're not getting anything out of it right now. So I currently have 24 volts power to the transformer, but through this switch I have it all off. And I can show that right here. I can go to the red switch right here, and we have 24 volts to the transformer. If I move this to the common wire, which is this blue, I can take this needle right here and my screen share just went away. So you can see on here, I'm going to move this right here to touch here, so that way you guys can see the common signal. And then we have 24 volts to the transformer. So we have 24 volts to that transformer right there. So now we're going to go ahead and put this back into the common terminal of the ECM motor. And then we're going to move this to a speed tap. This is going to be our 24 volt hot, so we're going to select speed tap 2. So right now we don't have any 24 volts going to our module to tell it what speed to run. But as soon as we turn this on, I'm going to turn the power to send power through, and then turn the green wire, because that's what I'm using. And then this motor is going to start up. So now this motor's running, and it's running at speed 2. And that's a lovely bent shaft that it's got. That's why we're using it, because it's a broken motor. So we can see coming into here that we have 120 volts going into there. We got 120 volts coming into our motor, but what do we have actually coming out of the motor? We need to go to DC, and we go to our DC speed, or DC volts. You can see we have 115 volts DC on there. Now, that's at 115 volts right there. Now, what if we were to move this speed tap to a different location? So let's go ahead and turn it off. It takes a few seconds for the module to power down. So there's still power being sent to this motor, but not on every leg. This is a 3-phase motor. We have no power going to this motor right now. So we'll take our speed selection tap and we'll move it to number 4. Let's put it on number 4. So let's put the speed tap on number 4 and see what we get.
How scary.
Our voltage is a little bit higher than it was before, and that's how it's doing this. It's converting it into 3-phase DC. You'll see all 3 legs of the same voltage. Now, if I took this away, what is it going to do? It's going to run for a few seconds. I took its 24 volts away. It's still got some potential voltage in there because of this resistors, or not the resistors, but these capacitors in here. So let's go to speed tap number 5 and see if we get anything different. So we're going to turn speed tap 5 on. Pull the speed tap out. Turn this off. Let's get a better signal on here. Go to ground. Ground is going to be a better signal. What's up, Maddie? Oh, yeah? Alright, so we got that moved over. We're going to put this back on the speed tap, number 5. Get a better voltage signal. Trying to get to stay on there is not easy. So there's obviously a problem with speed tap number 5 on this motor. We'll move it over. Let's put it on number 4 again. Now our module's not happy at all. We should have continuous power on here. Well, there goes that failed experiment. Module is done. It's going to reset here in a second. Yep. So, but as you can see, it makes 3-phase DC power on this system. And there we go. So as you can see, it converts a single-phase AC power signal and then turning it into a 3-phase simulated DC signal. Now you could measure across those 3 probes on that motor lead, and you could actually measure the voltage that way too with AC power, but it's truly simulated DC voltage that's going to that motor. And not all 3 legs are turning that motor. One leg is a reference signal telling the motor what position it's in, because it doesn't operate the same way as a split phase motor or a shaded pole motor. Now, everyone gets hung up on these things, and they got to buy these fancy special tools to test them out to make sure it's the motor, not the board. If you can follow a diagram, and I've been talking about this for a couple months with some technicians. If you can follow a diagram, you can understand pretty closely what type of signal that motor is looking for. Now, there are motors that require 24 volts as a run signal, and then they use the 0 to 10 DC volt signal to tell it how fast to run. And then they still have their line power. I've been able to check every just about 99% of ECM motors that I've come across, I have not needed to have these special tools to check them, as long as you know what they're doing. Thank you for your smart face there that you just made. You got something to say? What do you have to say?
Something silly things might happen with these things, and I don't know why.
Okay, so I lost my train of thought now. So with the X13 and the Enduras and the majority of the constant torque motors, you'll find that if you have line voltage and if you have 24 volts going to any of the taps, that motor's not running. You obviously have a bad motor. And when I say motor, it could be the module or the motor. But we've gotten so far away from where originally when these ECM motors were being installed and being utilized, the module and the motor were separate. Now they're built into one. And it's very hard to find just the module unless you want to wait a couple days to get a module. So now we just go, okay, we don't have 24, we have 24 volt signal to a speed tap and the motor's not running. There's a problem with the motor. Now, if the motor's not running and you don't have a 24 volt signal on those motors, then guess what? You need to figure out why you don't have a 24 volt signal, and it could be the board. I had a customer who was so adamant because we couldn't figure out, was it the board or was it the motor that was causing the problem. And he's like, well, just replace the motor. It's got to be the motor, because if the motor's not working, it's the motor. Well, we come to find out that it's not the motor, but it was the board that intermittently the relay on the cool signal, because it had two taps, one for heat, one for cool. It wouldn't send 24 volts out on the cool signal, and the fan motor wouldn't kick on. He was ready to spend, I think it was like $2,200 to replace this broad ocean motor on this carrier unit. And it was going to be a waste of time because the board was the problem, which the board was fairly cheap. But you'd put the unit into fan, like you turn the unit to off from cool, put the fan on, and the fan constant speed terminal would send power. And the fan, if you put it into heat, the fan would go into the heat speed. And that's why I told the customer, I was like, I really don't want to replace a motor without knowing definitively what the problem is. And we went out there in the evening one night, and he goes, it's not running. I said, don't do anything. I get there, and there's no 24 volts coming out of the board, so we wound up not replacing the motor and just putting a new board in. Then I had another instance where, I don't know if most of you guys have come across where the ECM motor will continuously run with no call for the fan, no call for cool, no call for heat, and the blower's just continuously running. And what's happening is that there's a failure in the module, and you can just take away the 24 volts, and if that fan doesn't shut off, you have a bad module, right? Or you check to see if you have 24 volts constantly being fed from the board. Then I've had instances where the motor would work for seconds and then stop and then start working. And it wouldn't work in a certain DC signal range, because there are some motors out there, I think like the constant airflow motors, which are true variable speed motors. Some of them work off of a 0 to 10 signal, where they get a 24 volt run signal and then they get a 0 to 10 signal for how fast to go for like these units that are variable speed, the communicating systems and whatnot. Now, with ECM motors, I recommend to never go back to the OEM motor unless the unit's under warranty. I prefer to put a drop-in ECM replacement. Like, I'm not going to bash on the Mars. I had one sitting back there. I was going to use that for testing purposes. I had a technician that bought it. It was an X13 ECM replacement. He had an Endura, but I have a thing with Regal Motors, which is the manufacturer of Gentech, and I think Gentech has a superior product for all the ECM drop-ins. They make a drop-in just for about every ECM motor out there that replaces it. The difference between what Gentech is offering and what the manufacturer has is the manufacturer may have certain speeds set up a certain way or different speed taps not programmed. Why would you spend $600 to $900 on a motor just because it's programmed a special way when that Gentech motor will go directly in, plug and play, and do all that? Here, let's look it up and I'll show you. There's a whole catalog on what motors cross over to what, and then there's like adapters that change it over from one thing. So I can't find the full guided sheet that like breaks every motor down, but I found this. And you can see, so they got to replace the OEM X13 with the Evergreen EM motors and control modules. Now they have you can just replace just the module. Then there's the condenser fan motor, the X13 condenser fan motors, which I actually think they have a pretty slick product. I have one sitting over here. If you guys want me to show you how their drop-in PSC to ECM condenser fan motor works, it's actually pretty slick, and I think it's the best one out there. The Mars ones I was using before until I saw this one from Gentech, which is Regal, and I haven't looked back. It's slick. So, but yeah. Then there's the OEM ECM variable speed motors with the Evergreen Verse motor. So this motor right here, there's two parts to it. One, so this one is to convert from the 2.0, 2.5, the Gentech model 2.3s, the Eons, the 3.0 motors, and it's got a module that will also take like some of those 16-pin motors, and it goes through what they call a user interface. And that user interface you hook up and it works the same way. But it's pretty slick. A lot of this stuff has been changing a lot. There's becoming more drop-ins. I personally feel they have the most motors on the market for the ECM motors, but they have a drop-in for just about everything. I have a Mars blower drop-in. It can be a little irritating and complicated sometimes with the Mars one. It's not hard once you start doing it. It's just they're the same cost as the Gentech drop-ins, and the Gentech's just you plug them in and go. It'll spin one way, spin the other way, stop, wobble back and forth, and then go the correct direction. I think she has something she wants to say. What do you want to say, Maddie?
Sometimes it might keep going up and down, and it's kind of different.
What is? The air conditioner?
Yep. Even air compressors can do that. A lot of things can do it.
Okay. Thank you for your explanation. But there's all this stuff coming out with technology, and everything's going to solid state, and they're trying to tell us we need these special tools to do all these special things, and it's becoming to a point where a new technician can't afford to do this stuff. But I just want to show that ECM motors aren't really anything complicated. Do you have line power coming in? If you have the correct line power coming in to your module, whether it be 115 or 230 volts, do you have the correct power going in? Yes? All right. Do I have 24 volts going to these constant torque motors? I have 24 volts. Perfect. I got a bad module. And usually in that case, you just place the motor and the module all at once. Do you not have those things? Well, you don't need this $300 tester to tell you that, which I don't even think those testers work on the variable speed motors. You just got to understand how it works. So you got 24 volts. You got your line power. Now, is it a variable speed where it's a true variable speed, like on a communicating system, where it has 0 to 10 DC volts that tells it how fast to go, 1 being 10% of the motor speed, 9 being 90%, and 10 being 100%. So you just got to understand how they work. If you guys want to see more on the ECM stuff, how the Evergreen PSC to ECM drop-in works. It's actually really slick. It's not like the module and the motor are separate, and it's super easy to install. They're awesome. I've actually put them on every truck. There's 2 on every truck now because that's how much I believe in them. I haven't had a failure out of them once yet. The only failure I've had is a failure for a technician to understand how to install it. That was it. But yeah, I'm going to do a product demo on this Supco Jumper King. I've been using it for a few months now, probably like 4 or 5 months. And it's a really good product. At first, I was, along with my technicians, it's really gimmicky. But it's versatile and it works for a lot of things. I actually just bought 11 of them for the technicians. I'm going to do a little prize giveaway for the first technician that hits 1,500 points. And if you're watching, my techs are watching this right now and you hit 1,500 points, the first 10 to hit 1,500 points gets one of those. I just bought 11 of them. One's going to one technician for helping make the money funds to come up to do that acquired. So he's going to get one. So it's going to be the first 10 technicians. But yeah, if you guys have any questions on ECM Motors, drop me a comment down below. I'll try and do my best to explain it. And if you want to see about the Evergreen PSC to ECM drop-in, let me know. I'll do a video on that and how that works and how to install one of those. But hey, everybody, I hope you had a good weekend and keep on H. Yeah, go ahead. What you got to say, Maddie? What do you got to say?
Like, I like see these things on school when I go to school. Like, I see it to seal it off, and it's so weird. That's what I want to tell you guys is.
Okay. The mind of a 6-year-old. So, hope everybody had a good weekend. Hope everybody's summer was good to them. Summer seems like it's over now. And everybody keep on HVACing on. If you like this video or any of the other videos, hit that like button, subscribe, leave a comment, and as usual, happy HVACing.